Hello friends, in today's question, system shown in figure is in equilibrium and at rest. The spring and the string are massless. Now the spring is cut. The acceleration of mass 2m and m just after the string is cut will be. So these are the four options, and this is the figure in which 2m is connected with the spring with the ceiling, and m is connected with 2m with the help of string, and we have to find out what will be their respective accelerations when this string is cut. So first of all, let's assume that 2m and m is a complete one system. So, and it is also given that this figure, the system is in equilibrium. You can say considering two m and m as one system. So under this condition, let's draw the figure. So we have 2m as well as m. So we are considering them as a one system. So under this condition, we are going to have 3mg in the downward direction, and in upward we are going to have this force because of spring, and let us call that as Fs. So it's given that system is in equilibrium. System is in equilibrium. So under this condition, downward force will be equal to the upward force. So we can say that spring force will be equal to 3mg. Where Fs is spring force. Force due to spring. Now in the second part, as soon as the string is cut, so we can divide this into two parts. Let me write it here. Before string is cut, and in the second part, after string is cut. After string is cut. So as soon as the string is cut, the tension instantaneously becomes equal to 0. String is cut, you can say tension in the string becomes instantaneously instantaneously 0. Okay, so we can say tension T becomes equal to 0. But the spring for the spring its force will still have the same initial value. Still have the same initial value, which basically means that will be equal to Fs, and this is because of the inertia of spring. and this is because of inertia of spring. So under this condition, let's draw the free body diagram for both the blocks separately now. So we can say for block M, so this is M. In the downward direction we have mg, and we say, let us assume that it is moving in downward direction with the acceleration of am. Therefore we can say that m into am will be equal to mg, and m cancels out, so we get acceleration of am is equal to g, and this is in downward direction. So this is the first part, and now we are going to solve it for, you can say, for block 2m. For block 2m, this is 2m. In the upward direction we have the same force, spring force rather, Fs, and in the downward direction we are going to have 2mg, and let us say it is also moving in downward direction with the acceleration of 2a2m. Therefore we can write the equation as 2mg minus Fs is equal to 2m multiplied by a2m, and Fs is our 3mg. We substituted here, we get a2m is equal to 2mg minus 3mg divided by 2m, and m cancels out throughout, so we can solve that 2m is equal to, this will be coming minus g upon 2. So this is the acceleration of mass 2m, okay, but in the upward direction. Okay, so we can say in upward direction because of the negative sign. So we can say that a to m is g by 2 upwards and g is downwards. So option number A is the correct option. So from here we can draw a conclusion that am is equal to g downward, and a to m is g by 2 upward. Therefore option A is correct option. So this completes the question. Thank you.